Okay, so last week we talked about just one model, which is the one-sided search model. Now, let's give a quick review of this model because we're going to talk about some applications about this model in this class. So remember, we call this one-sided model because we only focus on the unemployed workers' behavior. Here, the employer, the person who employed this worker, basically you can consider it as a function called f. He just randomly give wage offer based on this distribution. Okay, so there's really this employer, that's true, but that's not a key factor here. It's just a random variable, basically. Okay, so this unemployed worker, he or she will receive a unemployment insurance benefit B at the beginning of each round, and then a wage offer with probability P. Okay, so this wage offer, like I said, is a distribution. This W follow a F of W distribution, and it has a lower and upper bound, which is 0 and W1. Okay, and then this unemployed worker may choose to accept this offer, become employed, or deny this offer and keep unemployed. If he is an employed person, because this is an infinite period model, it still has a chance, probability S, that he or she will be separated, meaning he or she is fired, no longer have this job. He'll go back to the unemployed status. And if he go back to the unemployed status, he will keep searching for the new job. So basically, this is a person who's employed, unemployed, employed, unemployed, goes back and down, because this is an infinite time horizon model, right? So there must be switching back and forth. At some point, it must switch because when the probability that he will never switch basically is 0, as long as the probability is positive. Okay. So, and this is the utility that this person has because it's an infinite period model. So the utility is summing over infinity number of period, and we discount each period with this discount factor or basically a discount rate. Okay, and then each period's utility is based on the consumption in that period. And the consumption is either WT, the wage in the period T, or the unemployed insurance benefit B. Okay, but like we said last time, this model is this equation is, or this utility function is too complicated because it has infinite number of period, right? So this one is too complicated. What do? We make it to a Bellman equation, a dynamic programming problem. Okay, so remember, we define VE of W as the value of being employed at the wage W, and VU be the value of being unemployed. Okay, and remember what we define by value. What we mean is basically the summing over the probability. Okay, VE of W, we can write it as 1 over 1 plus R. That's the discount factor, 1 period ahead. And this, so if you get the wage W, you're currently employed and had a wage W, then you will receive a utility U of W. And then there's a probability S that you will be separated. So separation probability times, if you're separated, then you get this utility value VU, right? And then there's a probability 1 minus S that you're not separated, then you keep getting this VE of W. Okay, so with this is the Bellman equation. We can rewrite it and finally get this important form of the VE of W. And then what we really do is define something called the reservation wage. Remember here, we don't really have the reservation wage. We're just conceptually define this W star. We don't really know how to calculate it. We just conceptually have this idea of W star, where this W star will make this person indifferent between employee status and unemployed status. And by that definition, it must be the case that VE of W star equals VU, right? This is employed at the wage W star. This is unemployed value. And these two values should equal to each other. Okay, this is by definition what the W star means. And by that definition, I know VU equals this. And then we can arrive at this. Okay. And then what I do is I demonstrate you the feature of this VEW function. Okay, I show you that basically the derivative of VEW with respect to S, the separation probability, is negative. Basically saying that if the separation probability is higher, then the value for you to be employed at any wage level is negative. Okay, and then I show you that the value of unemployment is given by this function. This is, again, using the same idea that, okay, VU is the unemployed unemployed value. Then you do 1 period discounting, and then your enjoyment of benefit B, and then 1 minus P probability, you don't get any job offer. There's a probability P you get a job offer. On the other side, then that means you have 1 minus P probability not getting an offer. If you're not getting an offer, then you keep being unemployed, so your value is still VU. And then there's a probability P that you are getting an offer. But this offer only has a value if it is higher than the reservation wage, or meaning the value is higher than the VU. If VE of W is higher than VU, I will accept this wage offer. If not, I'm not going to accept this offer. So I'm taking the max between these two. Okay. When taking the max means I always take whatever is higher, right? And then I basically do a expectation of this thing. That's this thing. So this is basically expectation of VEW. Okay. And then I do a lot of math. Remember, I insert something and change something, and do a lot of things. Even the last step, I do something called the integral by parts, which is something you should learn in your first year calculus, but you probably never use it. Maybe in some statistics course, but not in other course. But anyway, then the whole thing will gives you at the end these things, that VU can be written as this. Okay, and that gives you basically a function form of this VU. And you can see that VU is increased with B, also increased with P, but decreased with R and S. And more importantly, since we have the function form of VU and right now, we can go back and determine the reservation wage right now, because VU or R times VU, this whole thing, this thing is decreasing with W star, but this is increasing with W star. So this is increasing, this is decreasing. So it must be the case that there is a unique value of W star that makes this equation true. So that means we can use this equation to find the W star that we conceptually had before. And this is the graph we have. Remember, this is originally the graph from the textbook. But remember, the main textbook in the textbook, the main text in the textbook was a different model. It was a 1 period, if not maybe 2 period. I forgot. Anyway, it's not an infinite period model. Okay, so it used some different notation. But in my case, these things should basically be u of w, and this straight line is r times vu, and then when these two equal to each other, it gives me the w star that I want. Okay, graphically, what it shows is like this, and I remember I did talk about this last time. So if the b increase, what happened in this case? Because the VE of W doesn't really have B in it, right? It only has B in it sort of through the VU. But remember, after we set the W star to be a number, a fixed number, we calculate the W star, the VU become a constant. So that means VE of W doesn't change, or U doesn't change with this this B. Or put it another way. Remember, this one in our case should be written as U of W, and this one should be R times VU. And if B goes up, U of W doesn't change at all, right? But VU will goes up as the B goes up. So the whole line will parallelly goes up. And you can see that the W star is increasing. That makes sense, right? What it says here is that if the unemployment insurance is higher, then there's less incentive for you to accept a job offer. Okay, if you don't work, you can actually get, say, 30,000 NT dollar per month. If you don't work, then, I mean, even a job that gives you 32,000 per month, you might not accept that job offer, right? Because you have to work 40 hours a week to earn $2,000 extra, right? That's very little incentive. So as the unemployment insurance is higher, my reservation wage, the lowest wage offer that I can accept, is going to go up. That's the basic intuition. Now, how do I determine the unemployment rate in this one-sided search model? So to determine the unemployment rate, the basic idea is that the flow of workers from employment to unemployment must equal the flow from unemployment to employment in the steady state. Okay, so because in our setting, consider there's many workers. Each of them are trying to find a job. Okay. We will consider only one worker, but now consider it as many workers. Then each of them in a state, they could be unemployed or employed. And then in the next period, it could shift. Some people can go from unemployment to employed. And then some people can be separated and go back to unemployed. Right? So it goes back and forth. The key here is that in the steady states, the inflow and outflow should equal to each other so that it will balance. That's the steady state means. Okay, so the idea is that if the unemployment percentage is in the steady state, if the steady state number is U star, then this is employed percentage. percentage of people who are employed, right? Because it's 1 minus unemployed. So the separation probability times this is the percentage of people who are employed but then unemployed, separated, right? So this is from employed to unemployed. And this one is what? This is the unemployed percentage times probability of getting an offer, and times the probability that this offer is higher than the reservation wage. The F, remember, it is the CDF, cumulative distribution function. So F of W star is the probability that this wage offer is lower or equal to W star, right? But we are considering the probability that is higher than W star. So we must use a 1 minus F of W star. This is the probability that W is greater than W star. This is getting a wage offer at all. They both need to be true, right? This is a conjunction probability. So this times this probability. So this is the flow from unemployed to employed. Okay? Okay, again, this one, employed to unemployed. This one, unemployed to employed. And you solving for this unemployment rate, you will find that U star equals S divided by P times 1 minus F of W star plus S. Okay. And in the textbook, he defined this thing to be H of W star. But so it writes P times H of W star times U star, but it's the same thing. Okay, I want to consistently use the same notation, so I didn't write the H of W star. Okay, so graphically what I have is this figure. Again, we rewrite this as U of W, this as R times V of U, VU. This will determine the W star. And the W star is insert into this 1 minus F of W star. And the S and P here are constant. Then you find the U that equates S times 1 minus U and the U times P times 1 minus F of W star. That gives you the unique U star that solves the equation. Graphically, it looks like this. Okay? So this one determines the W star, the reservation wage. And then the reservation rate is used here to determine the unemployment rate, U. Okay. Now look at the increase of UI benefit B again. We talked about this already. So in this graph, the answer is easy. We talked about this already. So the R times VU increase. So the reservation wage increase. And the reservation wage in this graph only changed the H of W, right? So when reservation wage is higher, H of W must be lower. H of W is the probability that this wage is higher than this wage W star. So the higher the W star, the probability is lower, right? It must be the case. So it goes down. And when it goes down, the unemployment rate increase. So the model's prediction about raising the UI benefit is that it will increase the reservation wage and also increase the unemployment rate. Basically saying that if you raise the unemployment insurance, it will make people actually unemployed. Make people choose to be unemployed actually. The whole mechanism is that the reservation wage raise, so that some people, they get a wage offer but they decline it and they keep being unemployed. What about increase in the job offer rate? So the P, so the probability that you ever get a job offer is increase. Okay, VU also increase. You can go back and check, but I already talked about this. So VU, R times VU is increased with dot P. So reservation wage also increase. This is also intuitive, right? The chance that you get a job offer every period is higher. Because each period, the probability you get a job offer is higher. I have a higher reservation wage, right? I don't need to accept too low offer right now. Because if I decline this round, there's a larger chance that I will get a new offer next round. And because it's randomly drawn, if I don't satisfy with the current rate, the next round it could be higher, right? So as the P is higher, VU must increase, so the reservation wage increase. And the reservation wage increase, it will, again, make this lower. But remember, here we also increase the P, right? So P is higher. The whole thing is U times P times H of W star. So it's not clear whether it will increase or decrease, right? Understand what I'm saying? These two things are counter each other. So I'm here, the textbook gives you example where the power of P is actually larger. So the whole thing will actually increase. It will decrease the unemployment rate. But on the other hand, it could also increase the unemployment rate. Depends on the probability, the parameter that you set. Okay? Any questions so far? So I demonstrate you two possible channels that what happened to the model when B and P increase, right? But you could consider other factor like the change of R or S. I mean, that could also change what it looks like here. It could be in the assignment. I don't remember exactly what I put in the assignment though. Oh, by the way, I don't know if you guys should get a notification, right? I mean, the homework is due next week. Okay, March 29th. Yeah, sorry, I should have given you the homework earlier last week, but I was caught up in something that's really important on Wednesday. Yeah, on Wednesday. So I was too busy on Wednesday, and all the way I work until Friday. Then I had time to create the homework for you guys. So I give you some extra days to write homework. No problem? Okay, if so, we will take a longer break. We'll come back at 3:30, and then we will finish this chapter with the rest of the content. We'll basically talk about the second model.